Hello everyone. In this video we're going to be comparing two numbers and find out which one is larger. We have square root of 6 plus square root of 2 all over 2 and 5 pi over 6. Now we need to find which number is larger. Now when you're comparing numbers, there's quite a few different ways to do it, especially if you have exponential numbers. Then you can kind of compare the bases, in so many different ways. You can use some other numbers in between. But these are different. They're both irrational. But not only that, 5 pi over 6 is a special case of irrational numbers, which is called transcendental numbers. Okay, and of course the other number is called algebraic. Now how do you compare something like this? We have to use a special method, and this is where geometry will be used. Why? That's a good question, right? When you see square root of 6 plus square root of 2 divided by 2, what are you thinking? If you are thinking trigonometry, then you're on the right path. We'll talk about that in a little bit. Let's dive in. So 5 pi over 6 obviously also gives us an idea about the geometry, because we probably need to use circles, right? Cool. Let's get to work. So here's what I'm going to do. I'm going to start by drawing a circle. So let's go ahead and draw a circle. Let's see if I can draw a good circle. All right. Oopsie. Let's see if I can draw a good circle. Awesome. Now we can make this smaller, obviously. Let's make this circle smaller. So what I'd like to do with this circle is, first of all, I want to determine where the center is roughly. Let's say the center is somewhere here. It doesn't have to be accurate. And then I'm going to draw two radii. So here's what I'd like to do. And let's go ahead and use a different color here. Let me draw the radii. I want one of them to be like this, and the other one is probably like this. Okay, that looks good to me. Now, here's what I'd like to do. Since I want to use trigonometry, and square root of 6 plus square root of 2 divided by 2 should remind me something, along with the pi, I'm thinking trigonometry. Okay, we'll get to the details in a little bit. Now here's what I'd like to do. This is kind of like a sector, right? And I want to cut off the segment. So let's go ahead and connect these two dots with a straight line. Thank you, notability. And now I want this angle to be 150 degrees. Obviously, you can also replace 150 with radians, which is what we're going to do. And I want my radius to be 1. Why? Because it's easier. So here's what I'd like to do. I have a circle centered at, I don't know, C. Let's call that point C. Let's call this A, and let's call this B. So here's what I'm going to look at. I'm going to look at the arc, the minor arc, AB, which is this one, right? The minor arc, and the major is the other one, of course. And then I'm going to look at AB, the segment. Now, what do you know about the arc and the segment? If you look at the lengths, you probably know that the arc is longer than the segment, right? Obviously. We have a segment and a bump. Obviously, the bump is gonna, not the shortest distance between 2 points, that's gonna be longer, right? Cool. Now let's see where this takes us. So how do you find the arc length? Well, you need to find the circumference, which is 2 pi r, and then multiply by the angle in degrees or radians, doesn't matter, and divide it by 360 degrees or 2 pi radians. If you do 2 pi is going to cancel out, so on and so forth. Same idea. Now here we can simplify this. For example, let's see. I can first cross out the zeros, and then 2 goes into 36 18 times, and then 15 and 18 are both divisible by 3. So it's going to give me 5 over 6. And since r is 1, this becomes 5 pi over 6. Does that look familiar? Okay, let's go back and look at one of the numbers we're comparing. 5 pi over 6. Great. This is the arc length, which is AB, right? The minor arc. Great. What about the segment? What is AB? To find AB, we do need, by the way, I probably should use absolute value, but I guess you get the idea. So to find length of AB, I need to use trigonometry, a little bit of geometry. So let's go ahead and do this. Let's take that triangle out. So I'm going to draw that one more time. let's go ahead and draw this, and then draw something like this, and then connect them. Hopefully they're equivalent, right? I could probably make this nicer. All right, all right, all right. Cool, cool. And pretend that this is isosceles and this is 150 degrees. Okay, it's not, but hopefully you'll bear with me on that. And then we're going to cut this in half. And of course, if this is 150, subtract it and divide by 2, you're going to get 15 degrees on both sides. And then cut it in half like this. And then you're going to get a perpendicular, which gives us two right triangles. And of course, this is going to be 75 degrees, and this is going to be 75 degrees. You could also write them in radians, but I like degrees better. And now here's what I like to do. Take a look at AC and CB. This is AC and CB. They are radii, so these are 1. Awesome. So what do you know about the other lengths, right? If this is 1, what is this one? How do you find it? Well, you can use trigonometry, and the trigonometric function that associates with respect to this angle, of course, the adjacent side to the hypotenuse is cosine. So you can write the following. Cosine 15 degrees is equal to, and let's call this length x, and this is also going to be x over 1, or just x. Great. What is cosine 15? It is square root of 6 plus square root of 2 over 4. So this is what you should be thinking as soon as you see root 6 plus root 2 divided by 2. But wait a minute, it's not divided by 4, but don't worry, we're looking for 2x. So if you find 2x, it's going to be root 6 plus root 2 over 2, which is actually the segment AB. Make sense? So since the arc is longer than the segment, right, we said that, okay, the arc length is going to be greater than the length of this segment. And the arc is 5 pi over 6. And the segment is root 6 plus root 2 over 2. And we were looking for the larger number, which happens to be 5 pi over 6 in this case. Now, this kind of comparison requires some geometry. I don't know if there's another way to do it. Probably, maybe using some series. But if you didn't have, these weird numbers like pi, then you could probably follow a different path. For example, if you had something like comparing this number and 2, I guess they're close, and then you would be able to do something like this. You could go ahead and compare square root of 3 to 2, which is obviously less than 2. And then you can go ahead and multiply both sides by 4. That's going to give you 4 root 3. 4 root 3 is less than 8. And then add 8 to both sides. And then you're going to get this inequality. And this is actually square root of 6 plus square root of 2 squared. And this is 16. And then you take the square root and you'll get the answer. Make sense? It's a different approach because radical against an integer. Okay, let's go ahead and take a look at the numerical values, and then we're going to finish up. But this is our winner. All right, let's go take a look at the numerical values. So these are the numerical values, and as you can see, they're very different. 5 pi over 6 is definitely a winner with 2.61799 something. All right, let's get back to the video and finish the work. This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.